So now I will present on properties of trees. So tree is an undirected graph that signifies first, tree is connected and acyclic. Second, tree is acyclic and a simple cycle form if one edge is dead. Third, any two vertices can be connected by simple unit path. For example, if from point A to D there is only one path. Fourth, tree is connected and has n-1 edges. So here we have four vertices. So if you want to calculate the number of edges, just use this formula n-1. So 4 minus 1 we got 3 edges. So next is the traveling 6% problem. The traveling 6% problem is we need to find the shortest way to visit all the houses so that we can save all the time and the energy. So here is the time and point A, B, C and D. So from this we can create multiple ways for the sixth person to travel. So here let's say the initial point is A, and then from A to B to C, D and back to the A. So we need to calculate the shortest way. So here, based on the calculation, the summation of time for A, C, D, B, A is the lowest, which is 40 minutes. So path ACDBA is the shortest way for the sixth person to travel from each point to another point.
Bismillahirrahmanirrahim. Hello, my name is Muhammad Fairuz, and right now I will explain about spanning trees. Okay, before that, we need to know what is a spanning tree. So I will give a definition for spanning tree. A spanning tree is a connected graph using all vertices in which there are no circles. In other words, there are a path from any vertex to any other vertex but no circles. As you guys can see, we have the graph G. Vertex A, vertex B, and vertex C all are connected, which is they have their edges. And this is the example for spanning tree. For the first one, B and C not connected, so it is not there are no circuits. And for the in the middle, A and B not connected, and the last one, A and C not connected. So we can call all of this example spanning tree. Alright, method for creating a spanning tree. Okay, we have two methods, which is cutting down method and building up method. Okay, for cutting down method, the first step is we need to start by choosing any circle in the graph and then remove one of the edges in the cycle and repeat this process until there are no cycle left. For this example, we see there are big cycle, so we need to remove the edges so there are no cycle left, and then we see the last cycle, so we need to do the same step so there are no circle left. And then for the building up method, the first step is select edges of graph G1 at one at a time such that there are no circle are created, and then repeat this process until all the vertices are included. From the graph F, we need to choose vertex 1 and vertex 2, and then we connecting to this vertex, and then we connect to vertex 4, and then the last one we need to vertex 3, so we can have spanning tree. For minimum cost spanning tree, okay, the minimum cost spanning tree is the spanning tree with the smallest total edge weight. So we can use Krokel's algorithm. The first one, select the cheapest unused edge in the graph, and then repeat step 1, adding the cheapest unused edge, unless adding the edge would create a circuit. And the last one, repeat until a spanning tree is formed. So we start from vertex A. We see that A to B, the cheapest one is $4, and then A to E is more cheapest compared to B to E. And then we choose A to C, and the last one C to D, because C to D is more cheapest than A to D. So to know the legit of the spanning tree, we see the graph connecting not create a circuit. Right. We go to the shortest path from a fixed node to every other node. For example, cities and routers between them. Okay, we can use the Dijkstra's shortest path algorithm. The first one, mark all nodes as unvisited and assign to all nodes a tentative distance value. For the current nodes, calculate the distance to all unvisited neighbors. Update shortest distance if new distance is shorter than old distance, and then mark current nodes as visited. And the last one, choose new current node from unvisited nodes with minimal distance. Okay, to find the shortest distance, we need to make a table. So the first one, you need to list a node that have in the graph K. Okay, we have node A, B, C, D, E, and F. And then we need to set short distance and put the previous node also. Okay, we set A as our initial, so the short distance is 0. And then for the other nodes, we set as infinity because we don't know the distance yet. Okay, so we know that A is our initial, so we need to see unvisited node, which is which one is the shortest. So as we can see, A to B is the shortest because they have 2, and A to D is the longest. So repeat all the step as I mentioned before until the last node. So from here we get these are the example of shortest path from A to C. So this is we got when we use the Dijkstra shortest path algorithm. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nasrul Amin bin Muhammad Api, and my metric ID is 225651. Today I'm going to presenting my mathematic discrete project, which is tree analysis and sorting algorithm. Okay, for the sorting algorithm, what is sorting algorithm? What does it do? Okay, so sorting algorithm are the method used to arrange elements in a specific order within a list or array. Okay, so as a computer science student, we're going to face a lot of array problems. So this sorting algorithm might be helpful for us. Okay, so what's the function of this sorting algorithm? Okay, first thing first, it is essential for efficient data organization, optimizing search operations, enhancing performance, understanding algorithmic complexity, and data analysis in various fields. Okay, there is 7 different type of sorting algorithm, which is bubble, selection, insertion, heap, radius, squeeze, and merge, and each this method have a unique characteristic and efficiency. Okay, so for the tree visualization part in sorting algorithm, okay, why we use tree structure is because it's easier to understand their operation, and it's also comparative to analyze different sorting algorithm performance and efficiency. Okay, that's for the tree visualization. Okay, back to the sorting algorithm. So the first method is bubble sorting. I think this is easiest sorting method, which is we just need to compare the first two element. As we can see here, we just need to compare -2 and 45 and find which one is lowest and the biggest. Okay, as we can see here as example, -2 is lower than 45, so -2 is going to stay in the front, and then the rest will follow the process like the first one. Okay, for this sorting selection sorting, first we need to select first we're going to 20, and it's going to run to the whole, it's going to process the whole array, and then it's going to comparing each value of the array. Okay, so as example, 20 is the highest in the is array, so it's still going to stay here, and then at the end of the array we can see the number 2 is at the end, so it's going to swap the position with 20. That's for the selection. For the insertion sorting, we're going to use a key, just as example. We're going to take 5 as a key, and then we replace the 9 at the 5 position, and then after that we're going to replace the first 9 into 5. So that's the way how insertion sorting method do. Okay, for the heap sorting, it's quite complex because we're going to use both tree diagram and array. So basically, based on this array, we're going to insert all this value into the tree diagram, and we compare it as usual, the biggest, which the biggest and which the lowest, and the process will repeat until the array sorted. Okay, for the quick sort, we need to find one. We need to select one of this array value as a pivot, and then we, as this like this case, we use 2 as a pivot, and then we run through all the array, and we scan 8 as a highest value, and then we need to 8 is bigger than 2, and then we need to find the value that lower than 2. So the first value that we found is 1, so we're going to swap 1 and 8 position. Okay, that's all for the quick sort. And for the Reddit, is basically we using like a matrix system. We basically value it as a digit by digit, and we sort it from lowest to highest. That's for the Reddit. For the merge sort, we just merge the array value that we have. As we can see here, is merged into 2 part, and then from this value need to merge again, merge, and then after we individualize all this value, and then we can start to sort it manually, and then at the end we going to compile again the value, and the result is going to be the sorted array. Okay, for this summary, most of the array are have their characteristic and efficiency based on data or array that we use. So all of that seven sorting method have their average and worst case performance, and adaptability to partial sort data. So I think that's all for this part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Muhammad Adil bin Anwar, metric number 222355. And for today, I will continue with applications of tree and searching. There's many applications for tree and searching, but three of the most relevant one are file navigation system, autocomplete and autocorrect, and lastly are network routing. So for file navigation system, or a command line interface, which is CLI, or more commonly known by File Explorer in our phone and computer. As we are familiar, File Explorer sorts out files and folder and allow us to store and find files very easily. In this case, tree structures help greatly to ease the process by using file hierarchy. The directory folder will be represented by nodes, and the files will be represented by leaf. To see more clearly, in diagram 1, the folder user will be root and it will be connected to another folder which is home and connected to COS and lastly connected to CS101. And in the diagram 2, we can see more clearly for real life example. So for the real life example, you can see that we got folder user, and under folder user we got home, and another COS and CS101. So each one of these are actually the node, basically a node connecting to another node. So that's how our file navigation system works. So moving on to autocomplete and autocorrect. Have you guys ever texting with your friends and suddenly when you're typing an autocorrect change what you want to text into something else and it causes fights? Yes, autocorrect and autocomplete are another application of tree and searching. These features are very famous in texting platforms such as PowerPoint and Canva. This feature uses trie, which is TRIE, or radix tree as a dictionary. Each node will be represented by a single character, and the path from the root to a specific node will form a specific word. However, before this feature can be fully functional, the dictionary of valid word is required as a guideline. If you were to explain in an example, let's say you're trying to type apple, so you put in APPL. The software will recommend you the word apple, as apple is the valid words that contain in the dictionary. So for autocorrect, if you are trying to key in APPLO, which is apple, the software will autocorrect into apple, as apple is not contained in the dictionary. So the pathing for this process would be node A to node P to node P to node L and lastly to node E. So the diagram 4 will show a real life example of how autocomplete works. So in this Google searching engine, we just key in discrete spacebar S. However, there's many suggestions for us, which is discrete structures, discrete signal. Each of these suggestions are actually already stated in the dictionary. So because in the dictionary already have all these suggestions, that's why it's being suggested to the user. Lastly, network routing. So for network routing, tree-like network organize the routers and switches. Root will be represented root will represent core router or source, and it will be connected to other router which are nodes. The tree structure is very crucial in this routing as it helps transferring data packet with lowest latency and minimum cost. This can be achieved with the help of Dijkstra algorithm to find the optimal pathing. Without tree structure, the data transferring would be affected negatively and latency would be so high that it's not client-friendly anymore. In summary, some of the most relevant and prominent applications of tree and searching are file navigation system, autocorrect and autocomplete, network routing, and all of these systems actually use the tree structure to ease and effectively carry the required process. Basically, And searching helps to simplify the pathing for the system to allow it become more effective and user friendly. So this will be our references for this project. Okay, with that, let's conclude our presentation. And thank you very much. I bid to each one of you and see you next time. Thank you very much.